Okay, let's talk about Chebychev's theorem for a few minutes. So we have a problem here that says the average new car price is $36,250 with a standard deviation of $1,900. Consider a random sample of 600 new cars. Use Chebychev's rule to address the following questions and then round to the nearest whole number if necessary. So at least how many new car prices lie between $32,450 and $40,050? So here's what Chebychev's rule or Chebychev's theorem says. It says at least 1 minus 1 over k squared times 100% of the data of the observations and any distribution lie within k standard deviations of the mean. So what I like to do with questions like this is draw a distribution. Here I drew two. These are right skewed distributions, but Chebychev's theorem works for any kind of distribution. Whether it's right skewed, left skewed, bimodal, normal, bell-shaped, whatever, it always works. But I drew two right skewed distributions, the tails and the longer tails on the right side, which means they're right skewed distributions. Now let's tackle the first one. Remember, we want to solve questions like this. The basic strategy is to put the mean, this is right skewed, so the mean will be just a little bit to the left, but still towards the center. So the mean up here, there is mu, the mean, and there's sigma, the standard deviation. So we're going to put 36,250 right here in the middle. And so for the first question, we plot the upper bound of the region in question. It's $40,050, so it's somewhere over here to the right. It's obviously the bigger number. And then we plot the lower value, which is 32,450. It's over here to the left. And the idea is to figure out how many standard deviations is that distance. It should be the same either way. When I wrote these problems, I made them symmetrical like that. So how many standard deviations does it take to get from $36,250 to $40,050? Or you can ask yourself the question, how many standard deviations does it take to get from $36,250 to $32,450? And it's really easy with a calculator, especially if k is a whole value. 36,250, how many standard deviations do I need to add? Well, if the standard deviation is 1,900, if I add 1, I get 38,150, which is not what I need. I need 40,050. So if I add another 1,900, another standard deviation, what happens? Oh, yep, I get 40,050. So turns out this distance right here, I had to add the standard deviation twice, so it's 2 standard deviations. Now, just to double check ourselves, this distance here should also be 2 standard deviations. So let's see. If we want to say 36,250, start with the mean, how many times do I have to subtract 1,900? If I subtract it once, I get that. If I subtract 1,900 again, the standard deviation, what do I get? 32,450. So this distance, again, is 2 standard deviations. So all I have to do is plug in k equals 2. I'm talking about 2 standard deviations. So 1 minus 1 over 2 squared times 100%. Now, we all know that 2 squared is 4. So this fraction is 1/4. 1 minus 1/4 is 3/4, which is 0.75. So I have 0.75 times 100%, which, moving the decimal place twice, that's 75%. Now, that's usually where a Chebychev's theorem, basic application leaves off. But notice the question's slightly different than one you might have worked previously, because this one says how many. So we want to know how many observations are we talking about that lie between $32,450 and $40,050. So we need to find 75% of what? 600. So 75% of 600 is what? Well, remember to find percentages, you convert to a decimal form, so 0.75 times 600. Now you should know this. Think about time, 60 minutes. What's 3/4 of 60 minutes? It's 45 minutes, so 75% of 600 is going to be 450. So we're talking about 450 observations. There we are. Now, what about the second one? The second one is basically the same question, just with a different upper and lower bound. Here, I'll show you how to solve it just slightly differently, or I'll show you how to find the k value just slightly differently. So let's see. Let's put that 36,250 there in the middle again, middle left. Now our new upper bound is, let's see, 41,950, and our new lower bound is 30,550. But the idea is the same. How many standard deviations are we talking about? What is that distance in terms of the standard deviation? How many times does it take adding 1900 to the mean to get 41,950? Now you could do, just like we did before, add 1900 over and over again until you get 41,950. And that usually works, especially if the value of k is a whole number. It will work. However, if the value of k is not a whole number, that won't work. But there's actually a very easy way to figure it out always. And here's a way to always figure out the value of k. In fact, we'll do this a lot starting soon in chapter 6. What you want to do is find this distance in terms of sigma. So what you do is you subtract 41,000, the upper bound, so 41,950, minus the mean, 36,250, and then divide by 1900, the standard deviation, and that will tell you your value of k. Notice 3. So that tells me if I had added 1900, I would have needed to do it 3 times. So that's 3 standard deviations. Here, I'll do it again this way. So if I take 30,550, subtract off the mean, 36,250, divide by the standard deviation, 1900, watch, I get -3. Now, why is it negative? Because I needed to subtract 1900 3 times. But we can still say the distance is still 3. We don't have to, don't put a -3 there. For the time being, we're not going to deal with, say, negative values of k. In the future, that'll make sense that we'll have negatives, but not right now. Okay? So we're dealing with 3 standard deviations in this situation. But again, the question doesn't ask for percentages. If the question said, what percentage of the new car prices lie between 30,550 and 41,950, well, we would be done by just plugging into this formula, and you would get, so let's see, 1 minus 1 over 3 squared times 100. You've probably already seen this calculation. Let's see, that's 1 minus 1 over 9, since 3 squared is 9, so 1 minus 1/9, like so. But if we multiply by 100, just move the decimal place twice, we get 88.8 repeating. So we'll call that 88.89%. And again, if the question had asked for the percentage, well, then we would be done. But we need to find this percentage of 600. So we convert 88 back to this decimal. So divide by 100, get back to the decimal. And then multiply by 600, and we'll probably have to round this number. 533. So it says round to the nearest whole number. So we will say that is going to be approximately 533. Approximately 533 cars. Okay? If you have any questions, always feel free to use the Ask the Professor discussion board, and I'll be more than happy to help out.